Hello, everyone. Welcome back. Today we are continuing our discussion of parallel lines. However, today we're going to see how we can use those theorems we learned to help with proofs. So here's a proof that's kind of already done for us. We know that AB or A is parallel to B. So again, I like to highlight the lines that I have parallel in the same color. So I'm going to make A and B blue. And then I also know C is parallel to D, so I'm going to make those pink. So now what I want to prove is I want to prove 1 is congruent to 3. Well, 1's here and 3 is here. They are not on the same transversal. In order for any of my theorems to work, they have to share a transversal. So these are not on the same transversal anywhere. But let's see what we do know. So they kind of helped me out in that they did it partially. So it says 3 is supplementary to 2. Why do I know 3 and 2 are supplementary? Well, 3 and 2 are on the same transversal of D, and they're inside. They happen to be same side. So that means parallel lines implies same side interior angles supplementary. Now, if I look at 1 and 2, 1 and 2 are on the same transversal A, and the parallel lines are C and D. So again, that's the same reasoning. Parallel lines implies same side interior angles are supplementary. Now remember, we learned a theorem about angles that are supplementary to the same angle, and that is congruent supplement. So if angles are supplementary to the same angle, they are congruent. And that's my proof. So now we're going to try another proof. So we're going to do this one together, and then I'm going to have you try one on your own. So number 2, I have my statements and my reasons. And again, I have 2 pairs of parallel lines. So I know that AB is parallel to DC, and you know BC is parallel to AD. Again, I still think it's helpful to outline those in different colors. So I'm going to do AB and DC, and then I'm going to do BC and AD. And if you want, you can extend the lines if that helps. If it doesn't help, don't. So when I look at that, I'm looking for a relationship between D and B. Well, they're kind of in the same spot as the last problem we did. So I can use A or C, but I know that angle D and angle C are supplementary. And I also know that angle B and angle C are supplementary. And that's because parallel lines implies same side interior angles are supplementary. Now you can do that in 2 steps as we did above, but then I can conclude that angle D is congruent to angle B because angles supplementary to the same angle are congruent. So that was essentially the same proof as the one above. So I want you to pause and give number 3 a try and then come back. So hopefully you paused and thought about the sum, and now I'm going to kind of outline it for you. So the first thing I'm going to do is I'm going to highlight my parallel lines. So I know AD is parallel to FB. And in this case, I made them longer. And I know that CDA So that's this angle. Oops, I'm still on line. Sorry about that. I know CDA is congruent to BFE. And what I'm trying to get is the larger angle CDF. So what I'm trying to get is this larger angle CDF is congruent to this larger angle DFE. Well, if I look at that, I hope you notice when you look at that they're both partially on this transversal DF. So if I have that transversal, and I know those two purple lines are parallel, that means that this angle is congruent to this angle. And then I can add the red and purple together to get the green. So that's kind of the outline of my proof. So now I'm going to get started. So statements, reasons. I have AD is parallel to FB. And I know CDA is congruent to BFE. And that's my given. Then knowing that, I can say that angle ADF is congruent to BFD because parallel lines implies alternate interior angles congruent. I then can add those together, CDA plus ADF is equal to BFE plus angle BFD. And that's addition. And then, as I said before, when we were doing this in chapter 2, we were going to be able to shorten that. So I'm now saying you can start to shorten it. So we show our addition, and then you can just go to substitution. You don't have to show the angle addition anymore. So angle CDF is congruent to angle DFE. And there's my proof. All right, so again, I want you to pause and try number 4. Okay, so here's my proof. I stated my givens, then I looked at my first given. AB is parallel to CD, and I also highlighted the transversal JK. So that means angle JEB is congruent to angle EGD because parallel lines implies corresponding angles are congruent. And I knew I wanted to look at those two because those two are part of my next given. EF bisects JEB. So that means FEB, this little one, is half of JEB. And HG bisects EG. That means HGD is half of EG, definition of bisect. Then I know those two angles, angle HGD is congruent to FEB because halves of equal quantities are equal or congruent. So that's the end of our video. If you have any questions, please bring them into class.